Welcome, students, to Math with Mrs. Lehman. Today is Tuesday. It is the 3rd day of October. Today we're going to continue our work with unit rate and unit price. Before we get started, and that, by the way, that's lesson 20 in your module books, we're going to start with this math joke. It says, if my math is correct, we only gained 0.00976521 pounds per second on our cruise. Has anyone been on a cruise? Okay, when you're older, maybe you'll get the chance to go on a cruise. All they do is feed you. Like, you have tons of food. There's buffets all the time. So usually when people go on these cruises, they tend to overeat and gain a little weight. I wouldn't know what that is like. Okay, everybody good with that? They're really busting a gut here. The next one was your homework. We were going to finish 58 and 59. So one thing that we're going to focus on today, kids, is how to use a calculator. So on the kids' desk right now are calculators, and obviously in the real world we use calculators all the time. It doesn't obviously negate the need for knowing how to do those operations, but sometimes for efficiency we're going to use a calculator in 6th grade math, okay? Because it becomes less about the calculation and more about the concept and applying that calculation to answer a bigger problem. So I like to use an analogy about a refrigerator, okay? So I'm going to ask you a series of questions, and I want you to say yes or no, okay? Do you have a refrigerator at your house?
Yes.
Okay. In that, or do you expect your refrigerator to do your grocery shopping for you?
No.
Does your refrigerator pick out a recipe for you?
No.
Does your refrigerator prepare the ingredients? It holds the ingredients, but does it like measure out the ingredients for you? No. Okay. Does the refrigerator cook your food for you? No. All right. Does your refrigerator put the food out on a plate and present it to you at your table?
No.
Does your refrigerator do your dishes?
No.
Does your refrigerator put your dishes away?
No.
Okay. So what happens is a lot of kids know that about a refrigerator. What does a refrigerator actually do?
It keeps your food cold and stores it so it can be eaten it
keeps it cold, right? Basic function of a fridge, you nailed it, is to keep it cold. Okay? Because it refrigerates. A calculator, guess what? It calculates, right? So you cannot expect your calculator to read your problem for you. You can't expect your calculator to underline keywords. You cannot expect your calculator to figure out which of those numbers to use. You can't count on your calculator to do the operation that needs to be done. You cannot rely on your calculator to write your answer out and label it. All right? Somehow in 6th grade, kids see a calculator and they think it's a magic wand of math and that it's going to be the answer to all of their troubles. All right? Your calculator will do exactly what it says it's going to do. It's going to calculate. All right? Just like your refrigerator, if you put garbage into your refrigerator, it's going to keep that garbage nice and cold for you, isn't it? Your calculator, if you put the wrong numbers in there and push buttons, it's going to do exactly what you tell it to do, but it's still going to be essentially a garbage answer, right? So keep that in mind, please, as we use these. The other rule that I have when you use a calculator, and this is so that teachers can really see what you're doing and that you could follow your process with math. If you plan on typing anything into your calculator, you need to make sure that that is written on your paper. So for example, if you want to do 2 plus 2, hopefully you wouldn't need a calculator for that, first of all, but on your paper, you should have written 2 plus 2 equals before your finger touches any of those buttons. All right, are we clear on that, kids?
Mm-hmm.
All right, so starting today, we're going to use the calculators just to speed up some of these problems a little bit. So in question 58, It says Mitch needs to purchase soft drinks for a staff party. He is trying to figure out if it is cheaper to buy the 12-pack of soda or the 20-pack. The 12-pack costs $3.99. The 20-pack costs $5.48. Which pack should Mitch choose? Because he's looking again for the cheapest. Now, some people are going to say just automatically, well, $3.99 is cheaper than $5.48, right? When it says what is the better buy or which is the better deal or which is the cheaper price, it's referring to the unit price, okay? So you need to make sure you calculate the unit price before you make that comparison. All right? We're going to figure out the price per soda, all right? So think about your unit. You want the price per soda. So on top, what do I need to put? What would I put for my top number? I'm coming over to Jasmine.
$3.99.
Very good. $3.99 because that's the price. And then how many sodas will that buy us, everybody? Oh, wait. Sue Ann's going to answer. Go ahead, Sue Ann.
12.
Very good, Sue Ann. 12. Okay. So, again, on your calculator, type in 3.99 divided by 12. All right, so what did you guys get when you divided $3.99 by 12?
300. Alright. I forgot how to say it.
Okay, we can just do the digits for now.
0.3325.
Very good. So 0.3325. Okay. Now with money, how many places past the decimal point do we need to go? Percent. How many places past the decimal point? William?
2.
Very good. So there's the 2 spots, right? We got to look next door to decide, are we going to round that to 33 cents or round it up to 34 cents? What should we do?
Round it to 33 cents.
Very good, 33 cents. Excuse me. So we're going to say $0.33, and then we're rating the rate cap, right? So what would he say? Per, and it's referring to sodas. Yep, so 33 cents per soda. All right, that was for the first one. The second one, we have a 20-pack that costs $5.48. So what number do I put on top, everybody? Oh, nobody's answering. They're all of a sudden super shy.
548.
Very good, Sue Ann. Thank you. $5.48. And then that was for how many sodas? Deja, jumping in.
20.
Very good, 20. All right, go ahead and do that division, guys. All right, Carly, what did you got?
0.274.
All right, good. So 0.274. How many spots past the decimal place do we need to go? Or decimal point, I should say. 2, yeah, because they're throwing up. Not throwing up. Throwing up 2 fingers. They're using their nonverbals right now. I just should stop talking sometimes. Okay, so 2 places past. We're going to go to the next one. All right, that's a 4. So what's our rounding rule? 5 or above? 4 or below? Yep, so what are we going to do? Keep it at 27 or round it up? 27, yeah. So that's going to round to $0.27 per soda or per can. Maybe it's a bottle. We don't know. All right. So what is the difference between the cost of 1 can of soda between the 2 packs? So first of all, which is cheaper? We need to answer that question. Which is cheaper? The better buy for the unit rate. What do you think, Liz?
The better buy is 20. A 20 pack of soda for $5.48.
Very good. So Mitch should buy the 20 pack. What is the difference between the cost of 1 can of soda between the 2 packs? What key word is in there? What key word, Jasmine?
Different.
Very good. Difference tells us to do what operation?
Subtract.
Nice job. When you subtract 27 from 33, what do you get?
0.06.
Very good. So it would be 6 cents, 0.06. Again, we have $0.33 and $0.27. If you subtract, you would get $0.06. That's how much you will save per soda. Okay. Whoops. All right, Mr. Steiner is buying batteries in this next example. I'm going to pause the video. I'm going to let the kids work this one out and check their work, and then we'll come back with the answers here in your time, about 2 seconds. All right, so the kids worked this out. They said $7.20 for a 12-pack. Therefore, it would be 60 cents per battery when you divide. $12.49 for the 20-pack, so divide the 2, and you would get 62 cents per battery. Therefore, Mr. Steiner should buy which pack? The 12-pack for 60 cents per battery or the 20-pack for 62 cents per battery? Mackenzie, what do you think?
It's cheaper to buy the 12-pack.
Very good. The 12-pack's only going to cost him 60 cents for each battery. So I'm going to write it down here. Mr. Steiner, Mr. S, should buy the 12-pack. Whoops, that looks like a weird thing. The 12-pack. All right, what is the price difference? How much is he saving? Yes.
2 cents.
Very good. So Mr. Steiner is not going to give you his 2 cents. Mr. Steiner should buy the 12-pack. He will save $0.02 per battery. All right, we are now going to move on to a few more examples on page 56. Question 60 is our first one. It says the table below shows the amount of calories Mike burns as he runs. Number of miles ran. What are they counting up by? Carly?
By the number of miles, they're counting up by 3s.
3s, yeah. They're using an interval of 3, and that's consistent, right? They don't do any weird jumps. So 3, 6, 9, 12. And then what is the calorie burned amount jumping up by each time? Come into the back. Jaden hasn't been on our video today yet.
360.
Very good. Deja, you agree?
Yes.
Okay. So 720 plus 360. 720 plus 360. Hopefully you don't need a calculator for this. All right? 1,080 calories. All right? That's all we had to do for that question. Yep, that was just a little reminder that you do know how to do ratio tables. All right, we are moving down here to Emilio. He wants to buy a new motorcycle, and he wants to compare the gas efficiency for each motorcycle before he makes a purchase. Does anyone know what gas efficiency means? Have you ever heard your parent? Oh, Tim knows? All right, give it a guess, Tim.
Like saving gas.
Very good, saving gas. So if something's more efficient, you get more out of it, right? So you're going to go further with less gas, right? So you're going to have the most miles per gallon. Yes. Yes. All right, so we have a sports motorcycle that is Emilio's checking into in this leisure motorcycle, and they give us a ratio table for the sports motorcycle. Now to find gas efficiency, you're looking for miles per gallon. Even though in the chart they gave you gallons and miles, we're going to look for miles per gallon in that order, all right? So what do I put on top? What do I put on top? We're looking for miles.
287.5.
Very good. So we could use anything, any of these miles on the bottom row here. So Jasmine chose to pick 287.5. All right. What are we going to put on the bottom of that ratio? Jasmine.
5.
A different Jasmine. Yes, 5. All right. So we are going to put a 5 there because they're in the same, they're all part of that same ratio. Okay, so 287.5 divided by 5, go ahead and do that on your calculators. Be ready to tell me the label too. All right, what would Rady the Rate Cat say? All right, I'm going to ask Willow.
5 per gallon.
What per gallon?
Miles per gallon.
You got it, nice job. 57.5. And we took miles and divided it by gallons. That's why our unit is miles per gallon. Nice job. Okay, for the leisure motorcycle, before we can compare the two, we've got to figure out what the gas efficiency is for that. And they gave us this info via a graph, okay? So we are, again, going to take our miles and divide it by our gallons. So, miles divided by gallons. Who can tell me what we could use for miles? Jaden.
We could use the 110, for example.
Very good. Yeah, on this graph, luckily, the points intersect, or the points fall at intersections. If you're looking at a graph where that doesn't happen very often, make sure you look for a point where it does, okay? Because otherwise it's kind of unclear what you're dividing. But in this case, 110 is very clear for us to see. And the gallons, how many gallons would it take you to go 110 miles on this leisure motorcycle, Jasmine?
2.
2. Very good. So we're going to divide that by 2. What's 110 divided by 2? Timothy? Hold on.
55.
Very good. And what unit would that be?
55 miles. No, gas.
Think about what Rady the Rate Cat would say.
55 miles per gallon of gas.
You got it. Nice job. So 55 miles per gallon. You may see MPG written, right? That means miles per gallon. All right, so we now have to decide, based on the gas efficiency, which one would he buy if he's looking for the most efficient bike? The most efficient, Liz.
The leisure motorcycle.
The leisure, he would say. Yep, leisure. Yep. All right, very good. So, let's see, it says, which motorcycle is more gas efficient? Actually, no, that's incorrect, right? You want to go that's the one that he would go the least distance on for 1 gallon of gas. We want the bike that's going to take us the furthest, I should say. I know, because we just finished doing a bunch where we were looking for the cheaper one, right? So, again, I almost wrote that incorrectly up there too. So we just have to make sure we're paying really good attention. If you're looking for the best gas efficiency, you're looking for the one that goes the furthest distance with per gallon. Yes.
And the answer is the sports motorcycle.
Final answer, everybody? All right, that was like one child again. Final answer?
Sports motorcycle.
You got it. All right. So the sports motorcycle is more efficient by how much? 2.5. How did you figure that out?
Because 7 is 2 more than 5, and then you add on the 0.5.
Very good. So you just subtracted essentially in your head. So sports. Let's write the here. Whew. All right. The sports motorcycle is more efficient by 2.5 mpgs. Are there any questions? Okay, I'm going to pause the video for questions, and then we will wrap this video up for today. I'll be back in no time. Okay, guys, we are done with this lesson for today. We are actually going to continue with it more tomorrow. So before we leave here today and before we end this video, first of all, make sure you click that thumbs up sign down below, please, and make sure to subscribe. The last thing I'd like to ask you is, to find unit rate, what do you need to do?
Divide!
Woohoo! Nice answer, guys. I'll see you tomorrow on Math with Mrs. Lehman. Thanks.